Hey everybody, Mr. Smith here. Welcome to this video lesson. In this video, we're going to be starting a new unit, talking all about quadratic equations. We're going to talk about what quadratic equations are, what their graphs look like, and what different ways we can write them. So remind you, a quadratic equation creates a shape called a parabola that looks kind of like that. This poor dude getting his face destroyed by the volleyball. So this is a new unit that we're starting today all about quadratics, specifically how we write them using different forms of the quadratic equation. Before we get into actually writing quadratics, we've got to talk about domain and range. We referenced this a little bit already. So a little bit of review. Domain, that means all the x values where a function exists. That's what the domain of a function is. All the x values where a function exists. Range, on the flip side, is all the y values where a function exists. And I'm going to tell you what those two things mean, where a function exists. So when we're talking about domain, we're talking about x values, and when we talk about range, we're talking about y values. Okay? So let me show you on a graph what I'm talking about here. So if I'm looking at this graph on the left-hand side and I want to know what the domain and range are, remember the domain has to do with x values. So I'm going to read this graph along the x-axis, that's going left to right, and I'm going to move my eyes along the x-axis going left to right, and I'm asking myself the question, does the graph ever stop? Okay, is there any part where it stops moving from left to right? And the answer is no, because it's going to go forever this way, and it's going to go forever that way. So as I move to the left or to the right, it never stops. That means the domain is all the real numbers, which remember we kind of abbreviate with that weird R, 2 lines behind it. Talk about that in the first period class. Okay, what about the range? Range is with the y-axis, right? So I'm moving up and down. I'm looking on the y-axis, moving up and down on my function, and I'm asking myself the same question. Is there any place, if I'm reading top to bottom or up and down, is there anywhere that the function stops? Okay? And in this case, there is, right? If I go up, the function goes forever and ever and ever. But if I move down the y-axis, my graph actually stops right there. Don't dip beneath that value right there. So I need to go figure out what that value is, okay? It's 1, 2, 3. That's at y equals -3. So this tells me that my graph does not go anywhere beneath y equals -3. That means my range gets cut off. So the way I'm going to write this, I'm going to write it as an inequality. Okay, so I'm going to say that the range is all of the y values that are bigger than -3. All the y values that are above this cutoff point, because that is where my graph stops. I have to be above that line, which is at -3. So I'm going to say all the y values that are greater than or equal to -3. And there's my range. Okay. Let's do one more just for sake of time. We'll do this very last one on the right-hand side here. I want to keep these videos as short as I can. If I want to talk about the domain and the range, okay, so the domain are my x values, right? So if I'm reading left to right, my graph goes up that way forever, it goes up that way forever. So if I go left and right, it's never going to stop. That's my domain is all the reals. So I'll give you a pro tip right now. If you're dealing with a quadratic equation or a parabola looking shape, your domain is pretty much always going to be all the real numbers. So just keep that in mind. Range, looking at the y-axis, moving up and down, I'm asking myself, is there a point where my graph stops? And the answer is yes, right? I stop right there. I don't dip beneath that value on the y-axis, and that's at y equals 1. So again, I got to say that my range is everything above this line. So I'm going to say all of the y values that are greater than or equal to 1. And there's my range for that graph. Okay? So we'll talk more about domain and range as we move along, but there's my thought process to how to find those things out with a quadratic equation. Okay. Let me tell you about a couple of pieces about a quadratic equation, or parabola in specific. Remember, that's the shape that a quadratic equation makes. There are some technical terms that we need to know. Parabola, like I said, that's the graph of a quadratic function. Looks like that. Could also be a upside down like that. Okay. The axis of symmetry, that is the line that divides the parabola into two parts that are symmetric. That is basically a line that cuts a parabola in half. All right, so if we've got a parabola down here, we've got two parabolas down here. The axis of symmetry is the line, I'm so bad at straight lines. The line that cuts a parabola directly in half, that is your axis of symmetry. So if you just split it right down the middle, that line is what we call the axis of symmetry. The vertex is the point where the parabola intersects the axis of symmetry, meaning it's kind of like the middle point. The vertex is the most important part of a parabola. Okay, we're going to use that word. I'm going to use that word a lot. We're going to use vertexes a lot throughout this class. So the vertex is like that middle point on a parabola. We cross the axis of symmetry right there. That's the point directly in the center of the parabola. The vertex will also tell you a maximum or minimum value of your function. Okay, and we'll talk about that a little bit more later as well. Specifically, remember the vertex is a point, right? It has an x and a y coordinate. The y value of the vertex in particular will be either the maximum or minimum part of your parabola, either the biggest that the graph ever gets or the smallest that the graph ever gets. Like I said, we'll talk about max and min a little bit more as we move along. Right? So I'm going to show you in this video the first form of a quadratic equation that we're going to focus on. We call it vertex form. Okay, there are going to be three forms of the quadratic that we look at in this class. Vertex form is going to be the first one, and that's kind of what this video is going to be all about. Vertex form of a parabola looks like this. F of x equals a times x minus h squared plus k. Think back to our transformations from the first unit. All these transformations still do exactly the same thing that they did before, right? So A gives you a vertical reflection. That's flipping over the x-axis. Adding and subtracting inside of the parentheses moves you horizontally, left and right. And remember, that's kind of the opposite of what you see. You got to flip it. And adding something on the end moves you up and down in a vertical translation. So all those transformations still do the same thing. But when we talk about vertex form of a quadratic, when the equation looks like this, a times x minus h squared plus k, there are a couple of specific things that we really want to focus on, okay? The vertex, which I said is the most important part of a parabola, the reason that we call this vertex form is because it's really, really easy for me to find the vertex just by looking at the equation. The vertex is actually the point hk, okay? So all I got to do is look at h and k, and those two values will tell me what my vertex of the parabola is. All right. Similarly, the axis of symmetry, meaning the line that cuts the parabola in half, is just h. All right. The one big thing that we need to think about, kind of the one weird thing that might trip us up, is that when we go to find the vertex here and we look at h, we need to flip the sign for h. Okay, we need to flip the sign for h. So whatever I see inside of my parentheses, I have to change the sign when I go to say that that's the axis of symmetry for the vertex. All right, and I'll show you what I mean specifically in this next example. So let's actually do an example of this stuff. It's asking us to graph this equation. It's in vertex form. We're going to walk through a couple steps here. So first, let's think about the transformations that are going on here. I got a negative sign in front, right? So that means I'm going to flip 1/2, right? I'm getting multiplied by a 1/2 in front of everything. That means I'm going to shrink. That's a fraction. -2 on the inside, that's moving me right and left, and since it's subtraction, it's going to move me to the right. So that means I'm going right 2, and then the +3 at the end moves me up 3. So those are all the transformations that are going on, just so we stay fresh with those. Let's think about the axis of symmetry. Remember, we said all we need to do is look at h, the number inside the parentheses, and flip it. That's a big thing. We got to remember to flip that sign. Okay, so whatever I see inside of there, I'm going to change the sign. So the axis of symmetry is going to be x equals +2. The vertex is going to be, the axis of symmetry is the x coordinate, right? And the y coordinate is just whatever k is, that other number. So it's just 3, and I don't need to flip that one. So that's why we call it vertex form, because it's easy to find the vertex. Okay, to graph this thing, we're going to use a table. We're pretty much always going to use a table to graph stuff in this class. So here's how we're going to do it. We've done a couple of these already, but these ones will be a little bit more interesting. So I'm going to build a table here. Big rule that we need to remember. When we build a table, we are always going to put the vertex. We're always going to put the vertex in the middle of the table. I think I've mentioned that a little bit already, but it's going to be really important for us now. So my vertex 2, 3 is going to be the point that I put in the middle of my table. And then I'm going to go up 2 points and down 2 points. Okay? So now what I'm going to do is take these x values in my table, take these x values, and I'm going to plug them into my function that I started with up here. Okay? So I know you guys, you're looking at this on a screen. I don't really have a ton of room here to go and write this all out, so I'll just do it kind of one part at a time. Let's choose 1 first. Let's do x equals 1. Okay? So if I'm going to plug in, I'm going to plug in x equals 1. My equation is y equals -1/2 x minus 2 squared plus 3. I'm going to plug 1 in for x. It's going to look like this. It equals -1/2 times 1 minus 2 squared plus 3. Now I'm just going to break this down step by step and figure out what the y value is going to be. So I got to do parentheses first. 1 minus 2 is -1 squared plus 3. Okay. Little by little. -1 squared is just 1, right? And -1/2 times 1 is just -1/2. So we can get to -1/2 plus 3. And if I do -1/2 plus 3, that's going to give me positive 2.5. Okay, so if I plug in 1, I get 2.5. 2.5. Okay, so that's what happens if you plug in 1. Now let's plug in 0. So give myself a little bit of room here. So I'm going to plug in 0 for x, and my equation is still the same, -1/2 x minus 2 squared plus 3. Plug in 0 for x. I'm just plugging in my x values from my table to see what my y values are. Okay, so parentheses goes first. 0 minus 2. That's -2 squared plus 3. -2 times -2, that's positive 4. So -1/2 times positive 4 plus 3. -1/2 times 4, that's the same thing as 4 divided by -2. That gets me -2 plus 3. You can always use a calculator if you need to there. And -2 plus 3 is 1. Okay. All right, so now here's another pro tip. When we go to create a table for a parabola, well, parabolas are symmetric, right? If you think about what a parabola looks like, they are symmetric. That means 1/2 of the parabola is exactly the same as the other half. And that's why we put the vertex right in the middle. Because once I get 1/2 of the parabola, I don't need to go plug in 3 and 4. I already know what I'm going to get for those because the parabola is symmetric. I can just copy these values up to the other half of my table because 1/2 of the parabola must look exactly the same as the other. Okay, so if I plug in 3, I'm going to get 2.5. And if I plug in 4, I'm going to get 1. So I don't even need to plug those in. I know that since the parabola is symmetric, that's what I'm going to get. Okay, so now let's go graph this. 4, 1. 3, 2.5, right there, 2, 3, 1, 2.5, and 0, 1. Those are my points. So let's get a graph in here. There's my parabola. Okay. Domain and range. Remember, if we're dealing with a quadratic equation or a parabola, your domain is pretty much always going to be the real numbers, which it is in this case. All the real numbers. If I move left and right, graph never stops. Okay, what about the range? Well, if I move up and down, if I'm reading up, okay, I got a graph, I got a graph, I got a graph. Then once I get to here, graph stops, right? So I get cut off at this line. That looks like it's at y equals 3. That's where my graph stops. So the range is going to be all the y values. I have to be beneath that line, right? That's where my graph exists. So I have to be beneath y equals 3. So it's going to be all the y values that are less than or equal to 3. And there's my range. Okay? All right. Let's see here. Let's do one more type of problem, and that will be it for this video. Okay? One more type of problem here. We want to know how to write an equation for a parabola, just given the points that it goes through. All right? Point that it goes through and the vertex. So we can use vertex form to help us do this. So let's write vertex form out. It's y equals a times x minus h squared plus k. Okay. And let's think about what we have here. We're going to take all these pieces that were given in this problem, and we're going to try to use them with what we know, which is a equation for vertex form. We're going to try to use these pieces with what we know to try to come to a desired outcome. That's really kind of 95% of what math is, right? It's just taking the pieces that you have and trying to use them in such a way to get to a desired outcome. So let's think about what we got. We know that our graph passes through that point, -7, -15. So it's just a point on the graph. So we can label that with an x and a y, because that's just going to be a point on the graph. We also know that it has the vertex, -5 and 9. So remember, the vertex, we can think of that as the points h and k. So that means -5 is h and 9 is k. So what we're going to do is take these values and plug them into the equation where they're supposed to go. Okay? So x and y are going to get plugged in for x and y. And h and k are going to get plugged in for h and k in my equation. Let's see what that's going to look like. All right, so y is -15 equals a times x is -7 minus h, which is -5. Notice how I did minus -5. I didn't lose track of that negative sign there. It's minus whatever h is. It's all squared, and then plus k, which is 9. All right, so maybe you noticed, oh my gosh, Mr. Smith, I still don't know what a is. That's okay. We can go solve for a because we have everything else in our equation accounted for. So let's solve this equation for a now. So -15 equals a. We got to figure out what's going on inside of our parentheses here. Remember our orders of operations. I just want to do parentheses first. So -7 minus -5. Well, minus and negative, that's the same thing as adding. So -7 plus 5 is a -2 squared. Okay, so I have -15 equals a. -2 squared, that's the same thing as -4, right? Because that's -2 times -2. I'm going to write this a little bit differently. A times -4. We kind of like to write the variables second, right? So I'm going to write that as -4a plus 9. Same thing. It means the same thing. Just rewriting it. Now we're trying to solve for a. Okay, so let's get rid of this 9. Subtract 9 from both sides. -15 minus 9, that's -24 equals -4a. And then if I divide by -4 on both sides, I will get +6 equals a. Okay. All right, so now you might be thinking, well, Mr. Smith, that's awesome that we know what a is, but I thought we were trying to write an equation, right? That's what this problem is asking us to do. But now we actually have everything we need in order to write the equation. Because, like I already said, we already know what h and k are. We already have the vertex. And now I know what a is, so I can write the general form of a equation in vertex form. Okay? Remember, if vertex form looks like this, y equals a times x minus h squared plus k. Well, I know that the h and k are -5 and 9, and I know that a is 6, I think, yep. I know that a equals 6. I can just plug those into my equation, right? And when we write the general equation, we want to have an x and a y, right? So I'm not going to plug anything in for those. So it's going to be y equals 6 for a times x minus -5 for h squared plus 9. Okay, remember, I'm getting h and k because I'm told that this is the vertex. And the vertex always is represented by h and k in my equation. We can simplify this just a little bit. X minus -5, that's like adding, so I can think of that as x plus 5 squared plus 9. And there you go. There's my equation in vertex form. All right, so what we did, we took x and y, the point that it went through, and the vertex, we plugged those into our equation. We solved it down for a, and once I had a, I used a and the vertex to write out the actual equation. Okay? Okay, so that's going to do it for this video. If you have any questions on anything that we did here, remember the great thing about a video is that you can just go watch an example again, slow it down, chunk it up, watch me go through something again if you need to. But as always, I'm around for help, so feel free to email me if you need anything, and we will see you guys next time.